Hello CS112, today I'll be going over a quick solution to Lab 1, as well as walking through the ungraded portion of this lab. So first I'm going to go through the ungraded portion of this lab, which has to do with using a tester file. This was to be submitted to GradeScope, but it is ungraded. So I'm at the home page of your Blackboard. I'm going to navigate over here to Lab Slides, and I'm going to click on testerpractice.zip. Once I click on it, it will download. I'm just going to open it up, and the first thing I'm going to do is I'm going to click and drag it to my desktop. I'm going to drag it to my desktop. So once it's at my desktop, I can just X out of that. And I'm going to be working in Visual Studio Code. One of my favorite things about this is that it has its own terminal interface, so I can open up a terminal within Visual Studio Code rather than having to open up a terminal or command prompt elsewhere. So the first thing I'm going to do is actually, the first step of using a tester file is actually getting to the location of the tester files in my code. So I'm going to CD to my OneDrive, then to my desktop, and I saved it in a folder called Tester Practice. So once I'm there, I'm already done with step one. I just want to verify I'm here. So yes, step one is to navigate to wherever your code, which is this net ID right here, as well as the tester files are. They all need to be saved in the same directory or folder. Directories and folders are the same things. So they all need to be in the same place. That's step one. And once we have gotten there, we can do step two, which is typing in Python space the name of the tester.py. Keep in mind, it's supposed to be the .py file here, not the txt. The tester file will access the txt file, to run it with your netid code. And then finally, your code file here. So the three arguments you need are Python, the tester file, and your code. You hit enter, and then it will compare the two files, and it will give you some output here. And how you interpret this output is it will show you what the tester expected as well as what it got from your code, and you need to make sure these two match down to the character. So if there was an extra space at the end or a tab character we don't have, we need to match it. In this case, if we compare each character, you will notice that there is an expected comma an expected comma after the word feet that we do not have in our code. So I'm going to deal with that now. So if you were to just open up the file you needed right here, if you were to just go to feet, do a quick comma, hit Control S to save it, and then rerun the, whoopsies, I did not mean to do that, and rerun the program, you will pass 4 out of 4 tests. So this is what project one and all of your projects pretty much are going to be about. You're just going to be plugging and shrugging with trial and error to pass the tester file. So now let's go to the actual graded portion for this lab. And to do that, I am going to go to wherever I saved my file that I'm going to be working with, which is in school ETA, I believe. Whoopsie daisy. Now that I'm here, okay, I believe it's this one. Yes, so this lab was a pretty basic input-outputs question, which, I mean, if you were working on the assignment up to this point, this should have been very easy. But however, the way this was worded through the normal equation for acceleration off, I'm sure as a lot of you know, the formula for acceleration is the change in velocity over the change in time. But the way that T2 was worded in this equation, I apologize if you can hear my cat right now. The way that T2 was worded in this equation is actually setting itself up to represent the change in time in and of itself. T1 is kind of a pointless variable in this question. So I'm just going to dive right into it, but we needed to ask the users for all of these numbers and then display the acceleration at the very end. And they didn't have any, you didn't need to have any of the super and subscripts as well as any specific formatting. You just needed to make it look clean and understandable. So I'm just going to quickly power through this. So V1 is going to be equal to, I am going to cast this to an integer. Int inputs, it didn't matter if you did integer or floats. Float might be more specific, but it didn't matter for this thing. So I'm going to say, please enter the value of V1 in meters per second. And if you want to put it on a new line, you can. I am not. I'm just going to add a space at the end so it looks a little cleaner. And the reason I'm casting my input to an int is because by default, input is going to be a string. So if they entered the number 60, it will be the string 60, and I need to do math with these, obviously, because I'm calculating acceleration, so I want them to be integers. So now we're going to ask for V2 and set that equal to, again, int inputs. And then at the very end here, I'm going to say, please enter the value of V2 in meters per second. And I spelled input wrong. There you go. And I'm going to continue to do this with the other two variables. So that is T1, which is the useless variable, int input, please enter the value of T1 in meters per, or sorry, not in meters, in seconds, with a little space at the end. Again, I apologize if you can hear my cat. He is really hungry right now. I will be feeding him shortly after this. So please enter the value of T2. I cannot see anything because of this message. So T2 in seconds. And then lastly, we are going to perform our calculation here. So in this case, it's going to be this formula, but without the T1. It's just going to be the change in velocity over T2. Now, something that I like to that I like to do personally while doing math equations in Python is wrap everything in parentheses, absolutely everything, because keep in mind order of operations, if we did V2 minus V1 divided by T2, the first thing it's going to do is divide V1 and T2 and then subtract it by V2 because of order of operations. So just to be safe, even if logically the order of operations makes sense, you're going to want to wrap everything you can in parentheses. So now this should yield 6, which was the answer. So I'm just going to print out for the user at the end the, sorry for my cat, acceleration of Sarah, I don't know if I spelled that right, of Sarah is, and then I'm going to do a nice little comma here. And then say my variable, another comma, and then meters per second, and I'm just going to do that for squared because we don't need to do the super subscripts. So now I'm going to interact with this program. So I'm going to call this program by typing in Python and then cat.py, hit enter, and it's going to ask me to enter the value v1. So the practice values were 60, 90, 3, and 5, and the answer was 6 at the end. So as you can see, I did get the final answer to be 6. Now, by default, it is going to be converted to a float. As you can see, it was after the mathematical operations. If I did want to have it clean and kind of like the output of the example was, I can simply cast this to an integer to get rid of that 0.0. So if I run that again, and 60, 90, 3, and 5, it will give me a cleaner output. So if you have any questions on any of this or the tester, anything's not making sense, please let us know, because this is literally just a small fraction of what you're doing for your project 1, which is due in a couple of days.